somewhere 400,000 light-years above your head. A machine the size of a tennis court just looked back in time and saw something that should not be there. Not a star, not a planet. A fully formed galaxy, sitting in a place where, according to everything we thought we knew about the universe, there should only be darkness and gas. When scientists first saw the data, some of them thought it was a mistake. They checked the numbers again. They checked them a third time, and then they realized the numbers were right. And physics, as we understood it, was wrong. This is not science fiction. This is happening right now in 2026. And by the end of this video, you're going to understand why some of the smartest people on Earth are quietly panicking about what the James Webb Space Telescope just found. Stay with me until the end, because the last discovery on this list is the one that even NASA scientists are struggling to explain. Let's start from the beginning, because you need to understand what this telescope actually is before you understand why it is breaking everything we thought we knew. The James Webb Space Telescope is not just a bigger, better version of Hubble. It sits almost 1 million miles away from Earth, far beyond the Moon, at a spot in space called the second Lagrange point. Out there, it stays in perfect balance between the pull of the Earth and the pull of the Sun, so it barely needs any fuel to stay in position. It carries a mirror over 21 feet wide, made of 18 gold-coated hexagonal panels that unfolded in space like a flower opening after launch. That gold is not just for show. Gold reflects infrared light better than almost anything else. And infrared light is the whole secret behind this telescope's power. Visible light, the kind our eyes use, gets blocked by dust clouds in space. Infrared light passes right through that dust like it is not even there. That means Webb can see stars being born inside clouds that would be completely invisible to any other telescope. Can also see something even stranger. Because light takes time to travel, looking further into space is the same as looking further back in time. When Webb points at a galaxy 4 billion light-years away, it is not seeing that galaxy as it is today. It is seeing light that left that galaxy 4 billion years ago. So the further Webb looks, the further back in time it travels. And that is exactly where things started to go very wrong for our understanding of the universe. Here's the first discovery, and it is the one that cosmologists are still fighting about. For decades, scientists believed they had a pretty solid timeline for how the universe grew up. Right after the Big Bang, everything was hot, dense, and chaotic. It took hundreds of millions of years for gravity to slowly pull gas together into the first stars, and even longer for those stars to cluster into the first real galaxies. According to the standard model of cosmology, big, mature, orderly galaxies like the ones we see today should not have existed until the universe was at least 1 billion years old. That was the rule. That was the textbook answer. Then Webb turned its mirror toward the deepest parts of space and found galaxies that were already fully formed, disc-shaped, and packed with stars at a time when the universe was only 300 to 500 million years old. That is like finding a fully grown adult in a maternity ward. These objects got nicknamed the impossible galaxies, because, based on everything astronomers thought they knew about how fast matter can clump together under gravity, these galaxies simply should not have had enough time to form. Some of them appear to already contain the kind of orderly spiral structure that usually takes billions of years to develop. Think about what that actually means for a second. If you build a timeline of the universe from the Big Bang to today, and you mark the exact moment when the first fully formed, orderly galaxy was supposed to appear, Webb found galaxies sitting way earlier on that timeline than the mark allows. It is not a small gap either. We are talking about galaxies showing up hundreds of millions of years ahead of schedule, in cosmic terms. That might not sound like much next to a universe that is over 13 billion years old, but in the early universe, hundreds of millions of years is an enormous chunk of the available time. It is the difference between a toddler and a fully grown adult showing up at the same birthday party. Researchers have run the numbers over and over, and the honest answer right now is that nobody fully agrees on why this is happening. Some scientists think star formation in the early universe was far more efficient than we assumed, meaning gas turned into stars much faster than our models predicted. Others think dark matter clumped together earlier and more aggressively than expected, giving galaxies a head start. And a smaller, more radical group of researchers is asking an even bigger question: whether the age of the universe itself or the way we measure cosmic expansion needs to be reconsidered. When you have serious scientists openly wondering if the age of the universe might be wrong, you know something big is happening. This single discovery has become one of the most cited and most argued about results in modern astronomy, precisely because it does not fit neatly into the model that cosmologists have relied on for over 20 years. But galaxies forming too early is only the beginning. Webb then found something even messier happening in that same ancient era. Astronomers using Webb identified an active merger event, a cosmic pileup involving at least 5 separate galaxies crashing together at a point when the universe was only about 800 million years old. Before this observation, the common assumption was that the early universe was still too young and too sparse for this kind of large, complex, multi-galaxy collision to be happening. Mergers like this were expected to become common much later, as galaxies had more time to drift toward each other and interact. Instead, Webb caught 5 galaxies in the act of colliding and merging at an age when the universe was practically still in its infancy. The data suggests this collision was actively reshaping the gas and material inside these galaxies, essentially kickstarting rapid star formation through the violence of the crash. This tells scientists that the structure of the early universe was already far more crowded, more interactive, and more chaotic than any model had predicted. Instead of a slow, orderly universe gradually building itself up piece by piece, Webb is showing us a universe that was already busy, already colliding, and already building complexity at a pace nobody expected. Put that together with the impossible galaxies discovery, and you start to see a pattern. Every single time Webb looks deeper into the past, the universe looks more advanced than it is supposed to be at that age. That is not a small inconsistency. That is a pattern that keeps repeating. And patterns in science are never something you can just ignore. Now, let's talk about something that might matter even more to you personally. Because this next discovery is not about galaxies billions of light years away. It is about whether we are alone. There is a planet called K2-18b, roughly 120 light-years from Earth, orbiting a small red dwarf star. This planet is larger than Earth but smaller than Neptune, and it sits inside what scientists call the habitable zone, meaning the distance from its star where temperatures could allow liquid water to exist. When Webb analyzed the light passing through this planet's atmosphere, it picked up chemical signatures, including carbon dioxide and methane, which on their own were already exciting. But then a deeper analysis picked up traces of a molecule called dimethyl sulfide. Here on Earth, there's really only one major natural source of that molecule, and it is marine phytoplankton, tiny living organisms in our oceans. In other words, on our planet, this chemical is basically a byproduct of life. Finding a possible signal of it in the atmosphere of a planet 120 light-years away sent a shockwave through the entire scientific community. Now, before you get too excited, it is important to be honest here because credibility matters more than clicks. The current detection sits at what scientists call 3 sigma confidence. That basically means there is still a real possibility, even if a small one, that this result could be a statistical fluke or caused by some unknown chemical process we do not yet understand. To be treated as a true confirmed discovery in science, results usually need to reach what is called 5 sigma confidence, which is a much higher bar of certainty. So, right now, this is not a confirmed discovery of alien life. It is a genuine, serious, published scientific finding that has forced researchers to admit that something on this planet is producing a chemical signature we currently associate only with biological life. More observation time on Webb is already being used to try to push this number higher. And the entire astronomy community is watching closely, because if this signal holds up under more scrutiny, it would be one of the single most important discoveries in the history of science. Imagine being alive during the week that humanity finally got real evidence that we are not alone in the universe. That is the scale of what is potentially at stake with this one planet. And here's something worth sitting with for a moment. This planet is 120 light-years away, which means the light Webb is analyzing right now left the planet's atmosphere 120 years ago. Whatever is or is not happening in those oceans, if there even are oceans, has already been happening for over a century by the time we get to study it. Every future observation, every new hour of telescope time pointed at K2-18b, is really just us trying to catch up to a story that has already been unfolding for generations. Scientists have already scheduled more observation time to gather additional data, and some researchers believe a clearer answer, one way or the other, could come within the next couple of years. Whether the final answer turns out to be life, or some strange chemical process we simply do not understand yet, either outcome would teach us something we did not know before about how planets and atmospheres work. Let's shift from life on other worlds to something a little closer to home, right inside our own solar neighborhood, involving one of the most famous and most studied star systems in the sky. The star Beta Pictoris has been observed by astronomers for decades, surrounded by a huge, bright disk of dust and debris. Scientists already knew of 2 planets in the system, but this disk of dust was so bright and so thick that it was effectively hiding something from view, the same way a bright spotlight can hide a person standing just behind it. Webb, using its powerful infrared instruments, was able to cut through that dust and detect the atmospheric signature of a 3rd planet, now called Beta Pictoris d. Webb picked up carbon monoxide, water vapor, and methane in the planet's atmosphere, essentially reading its chemical fingerprints straight out of a disk of debris that had been concealing it from every previous generation of telescopes. What makes this discovery important, beyond just finding one more planet, is the method itself. Webb proved that it can find planets hiding inside bright, dusty disks by reading their chemical signatures directly, rather than relying only on older methods like watching for a dip in starlight as a planet passes in front of its star. This opens up a completely new way to search for hidden worlds in systems that were previously considered too messy or too bright to search properly. Astronomers now believe there could be a significant number of planets hiding in plain sight across other star systems, simply because older telescopes were not sensitive enough to see through the dust surrounding them. Beta Pictoris d might just be the first of many worlds we are about to discover using this exact technique. It also has the widest orbit of the 3 known planets in the system, meaning it swings much further out from its star than the other 2, which raises new questions about how such a large planet could have formed so far from the heat and material near its star in the first place. Every answer Webb gives here seems to open up 2 or 3 new questions right behind it, which is honestly the best sign that a discovery is genuinely important, rather than just a minor footnote in an astronomy journal nobody outside the field will ever read. Now, here's one that sounds almost too strange to be real, but it comes straight from published, peer-reviewed research. Nearly 700 light-years away, in the constellation Microscopium, there's a hot Jupiter-type exoplanet, a massive gas giant that orbits extremely close to its star. Webb observed this planet closely enough to track its atmosphere changing over the course of its day and night cycle. And what scientists found was a genuinely bizarre weather pattern. On the day side, where temperatures are scorching, clouds made of vaporized rock and minerals actually form in the atmosphere. Then, as that same region rotates into night and temperatures drop, those rock clouds disappear entirely, essentially raining out or breaking down as the atmosphere cools. Then the cycle repeats the next day. Imagine clouds made not of water vapor, but of vaporized minerals, forming and disappearing every single day like clockwork, on a planet where an entire year might last only a matter of hours because it orbits so close to its star. This was one of the first times scientists had ever directly observed this kind of daily cloud cycle on any exoplanet, and it gave researchers an unprecedented, detailed look into the chemistry and physics of atmospheres completely unlike anything in our own solar system. A related study on a different planet even found 2 completely different types of twilight occurring on the same world, depending on which side of the planet you were standing on. Something that sounds like it belongs in a science fiction movie, but is backed by real spectral data. These discoveries matter because they are teaching scientists just how wildly different weather and atmospheric chemistry can be on planets that do not follow any of the rules that apply to Earth, Mars, or Jupiter. Before we go there, there's one more story worth telling because it shows a completely different side of what this telescope does. It is not always about ancient galaxies or alien biosignatures. Sometimes it is about protecting our own planet. There was an asteroid called 2024YR that, for a while, had scientists genuinely nervous. Early calculations gave it a small but real chance of hitting the moon, and even a tiny chance connected to Earth impact scenarios down the line, which is exactly the kind of headline that makes people panic. The problem was that this asteroid was too small and too distant for most ground-based telescopes to track with real precision. So astronomers turned to Webb, and its infrared sensitivity allowed scientists to refine the asteroid's size, its orbit, and its trajectory far more accurately than before. Based on that improved data, the impact odds were updated, and the risk level was significantly reduced. This might sound less dramatic than an alien biosignature or an impossible galaxy, but it is arguably one of the most practical, real-world uses of this telescope. It is a reminder that Webb is not just a time machine pointed at the ancient universe. It is also a tool that can be redirected toward objects flying through our own cosmic backyard, helping scientists figure out, with real evidence instead of guesswork, whether something out there actually poses a threat to us. In a strange way, this story is comforting, because it shows that when there's genuine uncertainty about a potential danger from space, we now have an instrument powerful enough to get a clear, precise answer, instead of relying on rough estimates and worst-case guesses. Let's go even further out, to the very fabric holding galaxies together, or at least what we think is holding them together. Roughly 85% of all the matter in the universe is something we cannot directly see, called dark matter. We only know it exists because of its gravitational effects, the way it bends light and holds galaxies together that would otherwise fly apart. Using Webb's incredible resolution, combined with older Hubble data, researchers built one of the most detailed dark matter maps ever created, containing roughly 10 times more detail than what Hubble alone was able to produce. This new map reveals clumps and filaments of dark matter in far sharper detail than ever before, showing exactly how this invisible material threads through and around the visible galaxies we can actually see. This is not just a pretty picture. Understanding the fine structure of dark matter helps scientists test whether our entire model of how the universe is built, called the Standard Cosmological Model, actually holds up under real observation. And remember those impossible galaxies we talked about earlier? The ones that form too fast, too early? Some researchers now believe that finer, clumpier structures of dark matter in the early universe might be part of the answer, potentially giving normal matter a head start in forming galaxies faster than plain gravity alone could explain. In other words, this dark matter map might be one of the missing puzzle pieces that could eventually explain why the early universe seems to have grown up way faster than the textbooks say it should have. And finally, let's talk about a visitor. Not from another star system in some distant corner of the galaxy, but an actual object that is passing directly through our own solar system right now, having arrived from interstellar space. It is called 3I/Epic Atlas, and it is only the third confirmed interstellar object ever detected passing through our solar system. This means it formed around a different star, in a completely different part of the galaxy. And after who knows how many millions or billions of years traveling through the emptiness of space, it happened to pass close enough for our telescopes to catch it. Webb pointed its near-infrared spectrograph directly at this comet and began analyzing the gas and dust boiling off its surface as it gets heated by our sun. This gives scientists something they almost never get: a direct chemical sample from a completely different star system, without having to send a spacecraft there ourselves. By studying what elements and compounds make up this visitor, researchers can start comparing the chemistry of other star systems to our own solar system, testing whether the same basic building blocks of planets, and possibly life, exist elsewhere in the galaxy, or whether our solar system's recipe is somehow unusual. Every single interstellar object we catch and study adds another data point to one of the biggest questions there is: whether the ingredients for planets, and maybe even life, are common across the galaxy or genuinely rare. So, let's step back and put all of this together. Because when you look at these discoveries side by side, they are not just a random collection of cool space facts. They are pointing in the same direction. Galaxies that grew up far too fast for our models to explain. A major cosmic collision happening far earlier than anyone predicted. A planet with a possible chemical signal connected to life, still being verified, but taken seriously by real scientists. A hidden world found using a brand new detection method that could reveal dozens more planets we never knew were there. Weather patterns on alien worlds that behave nothing like anything in our own solar system. A dark matter map revealing structure in far more detail than we have ever had access to. And a visitor from another star system, currently being read like a chemical fingerprint from a completely different corner of the galaxy. Individually, each of these is a major discovery. Together, they suggest that our basic picture of how the universe works, how fast galaxies form, how common life might be, how planets hide and reveal themselves, might need serious revision. The James Webb Space Telescope was originally designed to look back toward the birth of the universe and study distant galaxies. What almost nobody expected was that it would end up challenging some of the most fundamental assumptions scientists have held about cosmology, chemistry, and the possibility of life beyond Earth, all at the same time. We are still in the early years of this telescope's mission, and it is already forcing entire fields of science to rewrite their textbooks. If a single one of these results, especially the possible biosignature on K2-18b, gets fully confirmed in the coming months or years, it will be remembered as one of the most important moments in human history. The moment we got real evidence that life might exist somewhere other than Earth. Nobody knows yet which of these threads will lead to the biggest breakthrough. But one thing is certain. The universe Webb is showing us is stranger, faster, messier, and far more alive with possibility than anything we imagined just a few years ago. And if a telescope sitting a million miles from Earth can already be this close to rewriting the rules of physics and biology, it makes you wonder what we still have not even discovered yet. Think about the timeline of your own life for a moment. Every major scientific idea you were taught in school, about how the universe began, how galaxies form, how rare or common life might be, was built using the best data available at the time. But that data came from telescopes that, compared to Webb, were looking at the universe through a foggy, half-closed window. Webb opened that window fully for the first time, and almost immediately, the picture on the other side did not match the one described in the textbooks. That is not a failure of science. That is exactly how science is supposed to work. You build a model, you test it against new evidence, and when the evidence does not fit, you have the courage to admit the model needs to change. What makes this moment in history so remarkable is that we get to watch that process happen in real time, discovery by discovery, almost every single month. 100 years from now, students might look back at 2025 and 2026 as the years when humanity's picture of the universe quietly, dramatically shifted, all because one telescope, sitting a million miles from home, kept finding things that were not supposed to be there. If this blew your mind even a little, make sure you are subscribed because the next batch of Webb data is already being analyzed right now. And based on everything you just heard, there's a very good chance the next discovery will be even bigger than everything on this list combined.